Future Design Podcast.
This is Takatoshi Shibayama, and you're listening to the Future Design Podcast. Today I've got Bidushi Bhattacharya, founder of Astropreneur HUB and a former NASA rocket scientist. She's based in San Francisco, so she's joining us on video to talk about the future of space exploration. So, yeah, thank you, Bidushi, for being on the podcast. Very excited to have this. I've been doing lots of reading and stuff prior to this, so I wanted to see, what your thoughts about, all the things that I've been pondering about. So, the first thing I always wondered, even when I was a child, is, where can I find the next Earth? Where the exoplanets, right? And how far are we from being able to find one and go there?
They found a lot of Earth-like planets at this point. The issue is that they're very close to the stars that they orbit. I would say our closest cousin in terms of Earth is the planet Mars.
Okay.
It's accessible. You can get there in 7 months. And I definitely believe that the younger generation, I'm in my 50s, so somebody in their 20s right now will be part of a generation that does get humans to Mars. And there's just a wealth of information that we have to come up with between now and then. So there's a lot of work to do.
I've seen photos from Mars, and it's a very, it seems like a very red place. The sky is a bit red. The Earth, if you call it Earth, is red. It doesn't look anything like what we have here. And so, what do you mean by, it's the closest that, or I guess habitable next thing to Earth?
Well, it used to have an atmosphere, and it has water. So we haven't found signs of life yet, but it's quite likely. So I gave a lecture yesterday to some students in Australia on research that's going on the International Space Station, which orbits the Earth, and astronauts live up there. And one of the things that they do up there is they grow plants.
Okay.
And they're outside the pull of gravity, and they're trying to figure out, what will the plants do when they're not growing on the Earth. And one thing that's really interesting is you mentioned that Mars is red, which means it has a lot of iron oxide, right?
Yeah.
And we humans can't ingest that; we can't consume it, but plants can. So if you could figure out how to grow crops using the Martian soil, and we had people out there, they in turn could consume the crops that are living in the soil. So, if you're really going to go that far away, you have to have as much local sourcing of food, materials, everything as you can.
Yeah.
So I think that's key.
Right. And then it will basically be a vegetarian diet, though, right? Once you're there, because I assume you can't grow cows and chickens and stuff.
Well, I mean, have you tried a Beyond Burger yet?
I have.
Yeah. What did you
pretty
think?
Amazing. Yeah, it's pretty amazing.
It's supposed to be. I don't eat beef, but it's supposed to be like the real deal, I guess.
Yeah, it does taste. I don't eat red meat anymore, but it does taste exactly the same.
Does it?
Yeah.
Well, so the thing is, the reason people are getting into these Beyond Burgers is the raising that animal has such a large, environmental footprint. So if you go to a place, if you go off planet, I think you're just going to have to rethink your food supply and take the resources that you take with you and integrate those with what's available. So, it's kind of like migrating to another country, where if you take exactly the way you live in your current nation and you go overseas, you can't replicate exactly the same thing. You're going to have to make some adjustments.
Sure.
So, so I don't know about cows and chickens. I would imagine not.
Yeah. Well, I guess if you can replicate beef, you could probably replicate chicken or pork or fish. I guess maybe that would be an option. But is it even possible to raise cattle or chicken in Mars?
Right now, there's no atmosphere, so it wouldn't go very well.
So it would be like in a tent somewhere. You could create like a huge size tent where you grow cattle. Yeah.
The movie.
Yeah.
That's certainly, I think, would have to be the approach right now. I mean, people like Elon Musk talk about terraforming Mars, and that's going to be a long ways off. But you would have to have, if you're going to create some kind of a tent, like you're saying, I think you'd need a very large tent to be able to grow the grass so the cows can graze and so on.
Yeah.
Probably this cultured meat would be a better option.
I guess for the whole world itself, I guess, moving out of, growing
Yeah,
cattle and all that and moving on to more plant-based solutions is probably better for the world. You know,
yeah.
and but just going. You said it takes 7 months to travel to Mars. I mean, if you're an astronaut, you've been training for many years to be on this journey. But what about like folks like us? Can we actually endure 7 months being in a very confined, space shuttle, and with all the, well, actually no gravity at all, and you're just you're bunched with like a lot of people, several people. And I heard that if you're in a confined space with several people, then you start to get annoyed by everything that they do. Is that true?
Yeah. I mean, it's like being in a crowded house with your family over the holidays, right?
Yeah, right.
Yeah. No, but what you just brought up opens up an entire sector that I think is really going to be a field of the future. You're absolutely right. Astronauts are perfect in physical condition, right? They're actually perfect human specimens. They go up there. They don't have any illnesses or pre-existing conditions. But I mean, what happens when you put a middle-aged person who's taking medication for, say, high blood pressure, when you put them up there in space? How will they react?
Yeah.
And this is an issue that's going to have to be addressed fairly quickly, because there are companies talking about doing space tourism, taking people not to Mars immediately, but outside the pull of Earth's gravity to be orbiting the Earth, right? And that's going to happen fairly soon. And I've had discussions with my husband about how I want to take him up there for our 50th wedding anniversary.
Nice.
But it's happening, and it's real. And somebody is going to have to come along and test the effects of microgravity on your average citizen. So space medicine is an up and coming field.
Yeah.
And it's a very important field, not just because we talk about what's going to happen to humans when they get up in space, but space is a very unique environment. And you can do a lot of interesting things up there that you simply can't do down here. For example, you can develop pharmaceuticals up there that you can model only on the computer down here, but you couldn't actually create these long, protein crystals here on Earth because gravity would sort of break them down.
Yeah.
So space medicine is going to, I think, affect the pharmaceutical industry. It already has, helped to accelerate the testing of some drugs for bone loss. And then, I think that we're also going to need to get a much better understanding of, average human physiology in micro G. So it's not just the gravity and the confined space, because, people do live in Antarctica. They winter over, right? That's 6 months at a time.
Yeah, that's true.
We know if you have the right mindset, you can actually do that. And then, soldiers are, on submarines underground for like a year, under the water for a year at a time. But yeah, they are going to have to look at radiation as well. And the spacecraft, new materials will have to come up that can actually handle the radiation once you get that far away from the Earth.
Wow. And what about, we touched on gravity, but, you're weightless for 7 months and you arrive on Mars, and then there's gravity there. I mean, wouldn't that shatter the body?
Well, your bones will become weaker. That's a good point. But, one thing, I don't know if you've ever watched YouTube videos on astronauts, a day in the life of an astronaut. They actually have treadmills that they run on. They put on a belt and attach themselves to the arms of a treadmill, and they actually run. They keep, doing load-bearing exercises so that they can keep their bone density up. And this is where astronauts have a common problem with the elderly, right? Because the elderly also lose bone density. That's why they become so frail.
Yes.
And there are medicines being tested right now on the space station to manage bone density. So they would help not just people on Earth, but astronauts could take those medicines and prevent their own bodies from losing the bones, so that when they get to Mars, they won't have an issue with any sort of injury to their bones.
Right. I see. And what about the radiation that you mentioned? I mean, is there something that we are already trying to develop that, prevents getting radiation diseases?
Well, you have to get outside the Van Allen belts to really be exposed to radiation. And we don't know the long-term effects on, living tissue if you're out there for that long. but it's not good, right? We know that certain forms of radiation do cause cancer, and you don't want to expose yourself to that. So, another area that is developing fairly quickly is just the testing of all kinds of materials in space. And it's very straightforward now to test materials in low Earth orbit where the space station is. And we have students from our company that send stuff up there to test it. But what you want to do is develop tests that fly material maybe to Mars and back, not people, but you fly material there to see will it adequately protect the inside of the spacecraft. And you can also take, like cells. Yeah. Like just take some kind of petri dish with cells in it and see what happens to it when it's exposed for such a long time.
Right. I heard that a lot of the Apollo missions or any of those missions, a lot of them were just going up there and testing, certain things like, if for the lunar landing, they were testing the space suits, if it actually works, or if you can actually, move around in that on the moon. And they were trying to test that, or I heard that a lot of it doesn't it sounds very glorious, but a lot of the things were like more experimental than anything.
Yeah, I mean, it was the first time humanity tried something like this, right? It's pretty incredible that we got there and everything worked as well. But everything had to be tested.
Right. And then are we continuing to test these things?
Absolutely.
Yes.
There's new material out there for spacesuits that's being developed at MIT, for example. The former deputy administrator for NASA, Professor David Newman, is working on new kinds of material for spacesuits that's not as bulky. And I think they also are using smart materials that will actually, flex as you move. And there's also this interesting material called piezoelectric material that will generate electricity when it moves. So you could think about how you'd use that. This is great, cool stuff.
Because I heard that the space, if you move your hand, it's more like you have a kitchen, glove and you're trying to do like complicated, sophisticated things.
Yeah,
with
you're trying to screw something in. It takes a lot of dexterity. It's not easy, right?
Right.
I think the screwdrivers, the tools they have are all magnetized, because if you drop something, there's no dropping in space, right? It would just flow off to infinity. Yeah. So everything is secured. But what they did for the moon landing was done in 10 years, and it was quick. And it was done to meet a very specific goal of getting to the moon. We learned a lot. It's been 50 years since then, and a lot of technology has moved forward. And it's not just like the spaces. If you think about computers, right? I mean, if you think about how much computers have advanced, I mean, what I have here, this is just my cell phone. The computer on here would have been the size of this entire room. Yeah. Back then. Right. So, I mean, there are a lot of things that affect us on a daily basis that are an outcrop of the space program, like, the computers, the miniaturization of them and stuff.
Right. And then, we haven't landed people on the moon for a long time. And I assume that, there's a lot of dangers in putting people on the moon, a lot of costs. So it's better to send rovers there. But, is there going to be a time that we're going to try to put a person back on the moon again?
I think so. I think there are two major drivers for moving space tech forward. One is geopolitical. If there's a country you're competing against and you want to get there first, you're going to be motivated. And the other driver is economic. Okay. So the geopolitical stuff, there was the space race between the United States and the former Soviet Union, right? Yes. And everybody wanted to get there before the other. The new space race, the way I see it, is going to be in Asia. It's going to be India and China. Really? So China just landed on the moon recently, and the Indians are going to land there on the 7th, on the south pole of the moon. So they're all trying to one-up each other to see who's going to get there first. As far as the U.S. and Russia go, the funding situation is very unclear, and things change very quickly in the U.S. these days. So it's hard to say, what role the U.S. will play. But, this is where the commercial sector really can come in. And I think the reason that the space sector is growing so much is we have on the private side, people are starting to get the vision.
Mm-hmm.
And governments have done a fantastic job laying out the framework, right, and providing a very good base for space technology development, for space travel.
Mm-hmm.
It also did actually start with military missiles, right, that were eventually converted into rockets.
Sure.
And we know so much now we didn't know before.
Mm-hmm.
But this is a perfect place for commercial interests to come in,
Right.
monetize and keep building. And your motivations there would be very different. I mean, the competition would be a very different thing than geopolitical forces.
Right.
But I really do see that that's the area where we're going to have maximum growth in the coming years.
So you're saying that private corporations are coming in. So like the likes of Elon Musk or Jeff Bezos, getting into the kind of space race.
Yeah.
And I guess for them, I mean, they have a lot of funding, obviously,
Right.
as much as governments. And, with the technology that is widely available now, that you're saying that, it's not only geopolitical, but it's like, governments versus private corporations. Is that how it's going to be?
Partnerships. It has to be partnerships. And I know that the government space agencies will keep doing what they're doing. What they do, like when I worked at NASA, I worked on everything from the Hubble Space Telescope to the Mars rovers, worked on programs going to Jupiter. Nobody else can do that. That kind of resources just are not available to the average person. But
Right.
yet on the commercial side, I think one of the things that's a game changer now is the drop in cost.
Uh-huh.
So, Elon Musk has these reusable rockets, but again, my computer in here, this thing cost me like $800, something like that.
Right.
How much do you think a computer that powerful would have cost you even like 20 years ago? So we've got miniaturized electronics and satellites that are now being built for just like a few $100,000 rather than a few $100 million. And startups are getting in on the game, and smaller companies are building satellites. We're now at the point, and this is kind of amazing to me, we're now at the point where small handheld satellites will actually image every point on the Earth every day. And you think about the incredible power in having that kind of time resolution for data. So you don't just go and take an image from space of a storm and then go back 3 months later. You can watch and monitor regions for everything from fires to the development of retail centers and construction. You can monitor maritime. And those are the areas where people are really focusing on getting their finance, getting money right now, is those areas are being commercialized. So it's
basically, with your smartphone, you could just monitor the Earth, basically.
Well, I'm looking around. I've got a satellite here somewhere. I'd have to pull it out of the case. We have a CubeSat. You can go look on our website. The CubeSat basically, it fits in your hand. It's a 10 by 10 by 10 centimeter industry standard. And people are using those. You can stack 3 of them together, 5 of them, whatever. People are using those kinds of satellites, which are, you can kind of think of them as disposable. They're so cheap. So using them to image the Earth every day. And then they're not just selling the images. What they do is they use AI and different kinds of software to extract information from the images. And so let's just say you're talking about agriculture. You can get some information from space about crops and when they might be mature. And that's cool for the commodities markets and even for farmers. But if you combine that with ground-based data, let's just say you have sensors that measure moisture levels in the soil, you can get a whole picture of, what your crops are going to do in the future, which you would never be able to get with Earth data by itself or with space data. And, like with climate change now, we really don't have any, we can't refer to the past to kind of predict what's going to happen this year.
Yeah.
So it's pretty cool.
And who are the people who are actually making these things? It's not just NASA or ESA there has a lot of private corporations getting into the space tech.
There are startups doing it. There are startups doing it. So if you have a few $100,000, which may sound like a lot, but in the space biz it's not, you can build a CubeSat. We have one that we don't have the higher quality flight parts in, but these are all standardized parts. So we order our parts and build a few of them, just to use for a training tool for workshops. There's startups in the U.S. I know of startups who've launched these satellites from Europe, Eastern Europe, and then in Asia, you've got Japan. There are schools in Vietnam that are launching these satellites now.
Wow.
That's how accessible the technology is. And Australia, of course. Africa is starting to get in on the game. And of course, South America is there. So it's everybody.
Huh.
Yeah.
And you were promoting like Southeast Asia, or like particularly Singapore, as a place that you think you want to grow your space tech business. And why is that?
So we are a global business, right? I mean, Singapore has 5.5 million people. It's not an enormous market.
No.
I think the incredible value in being in Singapore is it's a very well-regulated place. People are very comfortable investing in businesses there. And I do see the potential for Singapore to become a financial hub for the space sector.
Right. I mean,
So
it already is a financial hub for many things.
Yeah, exactly. So it's a perfect stepping stone to get into that rest of the whole APAC region. And I think Singapore is, all the regulations are already in place to be able to finance these kinds of projects.
Right. And do you think Singapore would ever launch its own rocket or spaceship, anytime soon?
Singapore has launched these CUBE satellites that I'm telling you about. NUS has done it, NTU has done it.
Right.
But in terms of rockets, it's a very crowded part of the world where Singapore is. When you launch up and then you go over the ocean, you have to be over an uninhabited area for a certain period of time.
Is that because it might crash and debris might come down?
Exactly.
Right.
So you've got to go over open ocean. So if you look at most of the launch sites around the world, they go out over the ocean.
Right.
But if you've ever looked on a map, there's like this little strip, I think, between, Southeast Asia and maybe north of the Philippines where you could go through. There's not a lot of wiggle room there.
Yeah.
So there's no reason for everybody to reinvent the wheel. I don't think every country has to have its own rocket. But if you really, really want to do it, people are looking at mobile platforms for launching. Elon Musk has already started trying to land some of his rockets. They used rockets onto ships. So if you can go out to the middle of the Pacific, it's all huge, open wide. You could do it there.
Yeah.
But I don't see that Singapore necessarily would benefit from having its own rockets. Let somebody else take care of that.
But I mean,
share.
You were. I guess, looking through your website, you're trying to democratize space travel. If every country can have its own, launch pad to send people up into space, I mean, it's definitely beneficial. Let's say, the whole world is like blowing up and you gotta, like leave Earth for some reason. I mean, if you were, I guess at that point you wouldn't really care if debris falls on any parts of the planet, but but it's still, it's a necessary, infrastructure to have if and when you have to leave the planet, isn't it?
The big escape, right? The great escape.
Exactly.
I think that one of the things that SpaceX has been talking about, we're mentioning them a lot, is taking one of their rockets and sending it up in, say, the U.S. somewhere, putting it up really high into outer space, and then zipping across, and then landing, in Europe somewhere, all in the span of 20 to 30 minutes.
Yeah.
So if that kind of travel becomes regular, and we don't have to spend forever going, to an airport and, taking that 16-hour flight, I think that would be a step in the right direction. My hope is that just getting into space becomes as matter of fact as, driving from, one place to another just to go, visit somebody.
Yeah, I mean, that's a great point. I mean, there should be like pods where you can fly out, just like you go to an airport and get on an airplane. That would shorten that 16-hour flight. I mean, been waiting for that for decades and if not more. And Concorde was one of the fastest commercial airplanes that flown, but it wasn't economically viable. I mean, how long is it, and what are the necessary steps that we can take until these pods can actually be economically viable and then also affordable for us?
So that's the key, isn't it? Having
Yeah.
it be economically viable
Yeah.
and financially just accessible.
Yeah.
There are, some of these billionaires are building space tourism companies where people will be able to fly up, and they talk about, maybe in the next couple of years starting to send people up.
Mm.
And if they can scale that up to where it becomes about as affordable as, say, a first class airline ticket,
Mm.
I think you'll have a lot of takers.
Oh, yeah, definitely.
And, this is one of those businesses where, it grows just a little bit, everybody gets on board, and then it just grows really quickly because space is just, I always say about my job, space is such an easy sell. Everybody's inspired, everybody's excited and curious.
Mm.
So if you give people this opportunity to go into space, I think the whole sector will just really, literally take off.
Yeah. But I mean, astronauts are preparing for many years to get into space and do what they need to do there. I mean, for us common people, we just want to enjoy the ride, right? And just come down in a matter of hours or maybe a couple of days. But, surely we can't just, go to a rocket and just hop on and go, right? I mean, there must be like necessary physical tests or like preparations that we need to make in order to do this. And how would that look like?
So I actually wrote a LinkedIn article on this last year where I described what I imagined the process would look like. So the first thing I think is you would have to go through some kind of a medical clearance because the last thing anybody wants is to have a tourist go into space and have some kind of health emergency. So you'd have to be screened for that. And then you'd also, I think, probably want to take a couple of practice short flights to see how your body handles lack of gravity because a lot of people get very nauseous, right?
Yeah. I heard about the...
And so it's not very comfortable for people. So you'd want to do that to sort of check out how your body responds. But look, if you're going to go into space, into outer space, probably in the first few, that's a decade or so at least, it's only going to be for just a couple hours. You can orbit the Earth once every 90 minutes if you're in low Earth orbit. So let's just say you do 3 or 4 of those and then you come back down. Part of the reason astronauts train is the International Space Station is basically a research lab. What they do is they run experiments from people down on Earth. Like, we talked about plants earlier. So they do research experiments up there for universities, for companies, and also for students. That's part of what our business is. But they have to be technically trained to be able to handle all of these experiments across the board. You're just probably going to go up there and drink a glass of champagne and kind of look down at the Earth and be blown away and come back.
Yeah, I see.
Yeah.
But I heard, space motion sickness is a huge problem even for astronauts. And like throwing up in spacesuits is like a huge problem as well. I mean, is that how do people overcome that? And what are the training that people do to get through that?
So you ever heard of the vomit comet?
Yeah,
it's an airplane, that goes
up and down. Yes,
yeah. They a lot of times put students on that. I think some people's bodies are just wired so that they can handle it better.
Right.
It's like if you ever go to an amusement park, and some people can handle roller coasters, others simply can't.
Sure.
And the same with the spinning rides. So they do a lot of these kinds of tests with the astronauts to see if their bodies will actually be able to handle it. And having not flown in space, I can't say whether it gets easier every time, but it's definitely an issue that people will have to learn how to deal with.
Right. And also when you're orbiting at like 28,000 kilometers per hour, right? And that's
pretty cool. Yeah.
And I always wondered, like, so when the astronauts kind of go outside and they're fixing stuff and they're still in orbit, I mean, how do they even like kind of withstand that speed when they're outside?
So when you're in your car,
and
you're going 100 kilometers per hour, how are you like holding your phone or having holding on the steering wheel, having a cup of coffee?
No, I meant like outside of the aircraft. The spacecraft.
Well, they have. It's the same. There's no atmosphere, right? So they're in their spacesuits with oxygen. So they're being tugged along. They're tethered to the spacecraft. They're being tugged along the same as you would be here on Earth if there was no air. you happen to be sitting inside and it's, blocked off so the air is not rushing at you.
Right.
But, everything is relatively in motion around you. Your car seat doesn't move at a different speed from your body, right? You're all attached, so everything moves at the same speed.
Yeah.
This is the same thing that happens to them in space. They don't even realize necessarily that they're moving unless they look down, because they're moving at the same speed as the. So relatively speaking, in terms of the spacecraft, they're moving at the same speed. Does that make sense?
Yeah, it makes sense, but it's kind of hard to imagine. I understand there's no air, so you probably wouldn't feel the wind gushing into you, right? But
No.
But still, you're going at this tremendous amount of speed, and you're still outside, and then you see these videos of people just kind of floating around, but actually they're actually flying at 28,000 kilometers per hour, right? And that's something that's kind of hard to kind of connect in my brain.
Yeah, just think of it like your car. When you're in your car, you are going at 100 kilometers an hour.
Yeah.
The air inside your car is still, right? You're not getting whipped wind at your face, right? So you're not even aware that you're moving that quickly. If somebody else is driving, you really can't tell how far they're going unless you have visual clues, right?
Yeah.
You can look around you and see how fast the other cars are zipping by to know. But when everything around you is moving at the same speed as you, it doesn't matter whether you're going 28,000 or 100,000 or 2 kilometers an hour. It's all going to be relative, and you're going to feel like you're basically at rest.
Right. And also, the length that it takes to get to, let's go back to Mars again. And you said 7 months. 7 months is a really long time to be, just kind of sitting out there and observing. I assume that even when you look outside, it's just dark, and there's really, you can't, even with the sunlight coming from the back of you, you can't really see the stars either. So you're just pitch black everywhere. Is there I'm assuming every movie has this hibernation pod that people go into and do that. I mean, how far away from that technology?
Hibernation pods.
Yes.
You're talking about slowing metabolism down and having people sleep.
Yes.
I don't think we would want to develop that or need that technology for going out to Mars. 7 months isn't that long.
Right.
Now, remember when people go down to Antarctica to winter over, the scientists, they go down there, it's dark the whole time pretty much. And they'll be down there for, 6 months 7 months at a time.
Right.
So you, I would suppose what's critical for people's psychological well-being is to keep them busy with, say, running a series of experiments and, analyzing the data and just having something to do so that there's a structure to your day.
Right.
And, the other thing is when people used to take these sea voyages across the world,
yes,
back, say, like 200, 500 years ago, people did actually travel from one continent to another, right? And they did it fairly regularly. And those voyages could similarly take, they could take over a year.
Right.
So, I mean, you can't stop human curiosity. We've always had it, and we've always gone to new places.
Right. I see. And do you think that's even, well, people, who are on these sea voyages or people spending time in Antarctica, I mean, these are scientists and people who are dedicated to what they're doing. For us to go to Mars 7 months in a space shuttle, I mean, how can we keep ourselves busy? What do you think we can do to kill off that 7 months while we're up there?
What would you do on a long road trip somewhere? Let's just say you got in a car in Malaysia and decided to drive yourself over to, to Afghanistan. What would you do all that time? You'd read, you'd have the internet, so you'd probably watch movies.
You would have internet up in space as well, then.
They're going to have to communicate with the Earth. There's probably going to be a lag time, right? But the signals to tell the spacecraft where to go, what to do. A lot of that can be onboard AI, which is people are developing right now. But you're going to have to call the mothership, so to speak.
Right.
You're going to have to kind of connect with the Earth on a regular basis.
Right. So from Mars, how much of a time lag would it be?
It ends up when you're at Mars being something like 7 minutes.
7 minutes.
So if you were to make a phone call right now on your phone to somebody on Mars, they would receive the signal 7 minutes later.
Right.
And then they would say something and it would have to come back to you. So that's another, say, 7.5 minutes.
Mm.
So you say, hello, they get it. They say, hello, how are you? You hear back. That whole round trip time is on the order of 14 and a half minutes.
Right.
Long time.
And
that's when the two planets are at the closest to each other.
Right.
Remember, they go around the sun at different rates, so the distance does increase.
Mm. And is that because of like technological difficulties of getting it more simultaneous, or is that technology going to improve as well? Are we going
That's just the physics of the universe. Light is an electromagnetic signal, and it travels at a very specific speed, right?
Yeah. Sure.
So remember your basic physics from your high school days.
Yes.
The speed of light is the speed of light. So the thing here that's kind of mind-blowing for people is the vast distances.
Mm-hmm.
You know, I mean, the light travels at 300,000 kilometers in 1 second.
Mm.
Right. So, one of the most mind-blowing things is when we look up at the sky at night and we see stars and galaxies. That light has been traveling across the universe for, thousands or millions of years, and that bit of light has traveled and it hits the back of your eyeball. Mm. So that's what you're seeing is actual light that's been traveling through space for, up to, millions of years, even billions. Mm. And that is just a physical limitation. The speed of light, it can't get around that. I mean, if you figure it out, let me know. That would be pretty interesting. But we're just going so far. The distances are just so far that it just takes that long.
Yeah. So I guess, if we go beyond way more than that, I mean, it's going to take a lot more time to communicate. And, I guess, even with that, 7 minutes is, I guess it's okay. But, in times of like difficulties and when you have problems, you need mission control to help you out into something. I mean, even going beyond Mars sounds like a super dangerous task to do. I mean, are we going to even attempt to try to do that?
Yeah, I'm sure we will. You can't stop humanity, right? But you just have to design a self-contained system, right? So if you think about, say, the Europeans coming to the U.S., they took those ship voyages, right, back in, say, I don't know, the 1700s. Yeah. And they had to carry enough supplies with them to make it to the American continent. And then they had to have enough stuff with them to be able to build because, it was just a very, rural area here. So, and, on board the ships, they would have their cooks and their doctors and whatever else they would need. So we'd just basically be doing the same thing, just a few hundred years in the future and going, like a million times further in terms of distance.
And then is colonizing different planets like a really important thing for humanity?
Define important.
Well, I mean, scientifically, yes. For our human existence, is it something that we think that is necessary to do?
I think so. There's the sort of, emotional, sort of metaphysical reason we're all driven by space. But, this planet is becoming pretty crowded and we don't have all the resources required to support life. So, there's certain areas I see happening, where development will happen quickly. Mining the moon for material, mining asteroids, that I think is going to be a super lucrative line of business. And any materials that we can't find on Earth, we can go mine them from asteroids and bring it back. And you're not messing up. Mining is a very dirty operation, right? Lots of pollution. Yeah. You can just grab it from space and bring it back. Whoever figures out how to do this will be the world's first trillionaire, I predict.
Wow. I mean, I heard because there's no gravity, I mean, all this dust really like attaches to you or something, right?
It's easy to excavate, right? Because here on Earth, we've had hundreds of millions of years of geological processing. So if you get gold, I've got this rock here. I call this my Jupiter rock. See, you've got like all kinds of materials that are layered in here, and you'd have to break it up and use chemicals to leach out to the material that you wanted. But like you're saying, there's no gravity, and so there hasn't been any churning of the crust of these asteroids. So the material just kind of sits there. It's sitting pretty. You just have to go grab it.
And I heard there's a international treaty or some sort. Maybe it's a gentleman's agreement or whatever, but you can't claim anything in space. Like there's no sovereign claim to anything in space. Is that still held true?
Well, there are a lot of treaties out there, and there hasn't been enough activity for anybody to really challenge that. But people, again, are using Antarctica as a model for this because
Right.
nobody owns Antarctica.
Yeah.
It's a common research station used for a common purpose. And that's the model that I think people are going to try and implement in space. But it's kind of a tricky thing, right? I mean, because you have these satellites that are orbiting, and several nations have actually done some testing to blow up one of their own non-functioning satellites to see if they can deliver a kill missile to space, basically.
Right.
And it's their satellite. It's a public domain. Nobody owns it.
Right.
So they figure it's okay to do. I think 4 countries have done it, as similar to the U.S., China, Russia, and India, probably. So you go after you blow something up. It's yours. You figure nobody owns this. It's fine. But there are environmental implications because what you've just done when you've exploded the satellite is created thousands of pieces of space debris that are traveling at, like 10,000, X thousand miles per hour. And that can easily shred somebody else's solar panels, for example.
Yeah. I mean, I heard there's so much space debris out there with these shattered satellites and so on that there are startups actually going up there and trying to clean it. But I obviously there's no sovereign claim on space debris either, so nobody is putting up the money to clean this. I mean, how is this gonna play out? I'm very curious about that.
I'm going to guess that the insurance industry is going to be the one that's most interested in this stuff because as space becomes more crowded, you have to purchase insurance for your satellite, for your rocket, for all the systems.
Yes.
There are companies out there that specialize in space technology insurance. If you send something up and it's crowded at whatever altitude it's at, you would be most interested in mitigating risk for your products that you're insuring by making sure that there's less debris. So you would be motivated as an insurance company, I'm guessing, to clean up so that it reduces the risk to your assets.
Wow.
Yeah.
Wow. Insurance in space.
Yeah, it's the same.
Yeah, never heard of it. A couple of things I wanted to go through with you with it was still kind of interesting for me is gravitational time dilation. So, I guess you could. So I guess gravity kind of bends or weighs time, right? And so the same time that the clock's ticking up in space, and then Earth is different. And let's say you take that to Jupiter, it's much heavier, so the time clicks way slower. But what happens to? Do you think that has the same effect on the human body or kind of organic matter as well? Do you think that organic matter, kind of, I would say, decays differently in based on that time?
I guess what you're asking is the time in your own reference frame going to affect you just as it normally would, or whether because you're experiencing time dilation, something is going to be different?
Yeah.
So
exactly.
I think a similar argument to what we were talking about with the astronauts being, hooked up to that spaceship and traveling at the same speed, or you sitting in your car traveling at a certain speed. Everything that's around you is not affected any differently than it is when you're, standing still.
Right.
Yeah.
So I guess you wouldn't feel it, but then. Well, I mean, I guess Jupiter is not that far away, but
No,
but
it's only 40 minutes light travel time.
Yeah, I see. But because there've been some stories and movies that I've seen where people go to like closer to the black hole and come back and they're like much older than before, right? And compared to the person who was waiting on the outside. So, is that something that could really happen, you think? Or is it just the concept of time itself?
It is a concept, but remember, when you're writing a movie, when you're writing the script, you could put whatever you want in
exactly.
it, right?
I mean, I never really believed that, but...
It stirs the imagination, and, from a physics standpoint, yes, that could happen, where you leave and you come back and you're younger than your grandchildren, for example. People talk, when you take classes, you know, they have you do out the math on time dilation and stuff.
Yeah.
But as far as the actual technology goes, you got to put a lot of energy into getting your speed up that high. So I don't think we'll be testing it, you know, to that degree for quite some time.
Right. I guess it's not something you can test out anywhere.
Well, you'd have to go that fast, but we have tested it to some degree. Like what, you know, your opening question on this was you're talking about, you know, people aging differently, and they actually have, you know, done studies of astronauts, and they found that they age a little bit differently. There's a famous twin study where they've looked at the two, and one was up there and one was down here, and they've aged differently. Their genetic material actually changes to adapt to space.
Right.
It's incredible what the human body does, and plants, animals, all do this kind of thing where we will adapt in a way that people just never thought was possible.
Right. Yeah, I heard that even because there's no gravity, your spine actually lengthens as well. So spacesuits, you have to, come back taller, and you have to like also wear a spacesuit that adjusts for that extra growth that you'll get while up in space, right? I mean, but then...
So that's one of the specs, right? You have to make sure that you have a suit that grows with you.
Right.
Or just get a new suit.
Right.
So get a second suit.
So let's say, just going back all the way to the Mars story. So if we were to adapt to the environment in Mars, I mean, how would our bodies, do you think, would you know, evolve?
There's less gravity, right?
Yeah.
So there would be, we don't have long-term studies of what it's like for humans to be exposed beyond, say, a year to, you know, that's microgravity to lower gravity. But it's hard to say.
Yeah.
I mean, I think, you know, the biggest effects would be radiation and a lower level of gravity. And we'd have to make sure we protect ourselves in both cases, because we know lack of gravity causes brittle bones and we know radiation causes cancer. So, you know, right away, we've got to make sure we take care of those two to reduce the risk to whoever ends up going there.
And so how far away do you think it is for us to get to Mars?
Humans?
Yes.
Now, a lot of this will depend on whether we come together and share resources as a planet to get there.
Yes.
Because if you've got, you know, 7 different countries trying to get humans to Mars, it's going to go a lot slower than if we all work as, you know, as a united team and we share expertise. You know, you've got expertise in, you know, psychology. I've got expertise in engineering. If we can come together, you know, and create like a global space agency or global commercial space network, I would say it's not crazy to say people will get to Mars by the end of my lifetime, assuming I live to be 90 or 100. So say another like 50 some years.
Wow.
I don't think that's crazy, but we're gonna have to, you know, just come together, share knowledge, share information, and share resources.
Yeah, and I assume we're all doing that.
Yes, we try. You know how it is with that. It's, you know, some countries are very proprietary and everybody's got their own political agendas. If you're talking strictly about, say, the scientist culture, people share very openly. There's a common cause. What you really need to do is, on a commercial side, see that there are clear benefits to doing this. So these companies will actually cooperate with each other. Yeah,
and that's always the hardest part, right? The politics and corporates. Right. Okay. Well, thank you very much for your time. I mean, I never thought I had this kind of quality time with you, and you know, I really appreciate you, having this, creating this time for us.
Yeah, it's always interesting. I love hearing these questions. It's always fun.
All right. Thank you very much.
Yeah.
All right.
Okay. Take care.
All right. Bye.
Bye.
Future Design Podcast.